Alright, it's Tommy McPhee, and I'm about to spit a fire rap song over the physics of sound. 5/22/2016, 4th period, let's go. Alright, let's begin by saying the sound needs a medium on which to travel. As you play this rap song and watch your speakers rattle, vibrations oscillate particles in the air, which eventually reach your ear, which vibrates the eardrum, sending signals to the brain, which allow you to hear. Also note that we only hear waves of certain frequencies and amplitudes. 20 through 20,000 hertz is the frequency range that songs can use. Humans cannot hear sound too quiet, so they'll ignore them casually. So keep in mind your perception of sound is influenced by your anatomy. Now it should be noted there are two types of waves, transverse and longitudinal, but for the purpose of sound, transverse waves are unsuitable. The properties of these waves are determined by the source and the medium, but remember waves transfer energy, not matter or force. Square root of tension over linear density gets you the wave speed on a string, and remember the linear density is the mass divided by the length. Using a simple formula, you can find the speed of sound in a gas. Square root of Boltzmann's constant times tension and wavelength over the mass. Sound waves travel through compressions and refractions in the medium, variations in the spacing of particles in a waveform that keeps beating them. Although often thought of as a pressure wave, sound waves can be thought of as standing waves too. Nodes and antinodes, do they have them? All types of waves do. Sound waves can be constructive or destructive when they are superimposed. Just take the sum of the amplitudes of the waves and the resulting wave will be exposed. This can increase or decrease the amplitude, and if you go and try, you'll find it can change the volume. Large amplitudes sound loud, small amplitudes sound quiet. The frequency of a wave also affects its musical niche.
Higher frequencies sound higher,
and lower frequencies sound lower pitch.
Now when it comes to physics problems, this tip will help you solve a myriad. To find the frequency, just divide 1 by the period. Wavelength times frequency is equal to the wave speed. It's easy to see, substitute F for T. The formula is basically D over T. Now you should also know wavelength and frequency are related inversely, and sound waves are spherical, not one dimension or circle. See? The pitch an instrument produces depends on its resonance. A certain wavelength the pipe or the string gives preference. The reason for this is the placement of the nodes and antinodes, so a whole series of harmonic frequencies result. From this, everybody knows. First, let's take the instance of an instrument of string. Notes must be at either end for the frequency to sing, so each harmonic is a multiple of the lowest frequency. Multiply the fundamental by whole numbers to know what the harmonic series will be. When instruments with open or closed tubes behave the same, nodes at open ends and antinodes are at closed end. That's a trick to the game. Apply the fundamental frequency, the one that is the lowest, by a certain number, and pretty soon that harmonic, you will know it. Wind instruments with one end open and one end closed are a little different because of their structure. Only odd harmonics are able to sonically visit, and the fundamental wavelength is 4, not 2 times as long as the pipe. So when calculating these harmonics, make sure you do it right. Now through this rap song you've learned about the physics of sound, so after you take the test you'll have the highest grade around. You can even make standing waves with fire in a Rubens tube if you want, plus you won't even need to light it because this rap song is so hot.